Hi everybody, so today we're going to go over the notes that I started in class yesterday, Statistics Lesson 2. First, the concept of percentile. A percentile is the percent that of a group that is at or below a given measure. Now there's actually, in the math community, there's actually two debating definitions of this, which is weird because you would think that there would be one definition, but there's actually two debating definitions. One is, some people define the percentile as the percent that are at or below a given measure, and other people believe that the definition is the percent that are just below, not at. So depending actually on where you see this question and who has written the question, they might define it either of the two ways, but it'll be clear. So for example, you might see a problem that says like, you'll see it on your homework, which I had you skip it for that reason, but I think it's number 2, and it says like, Matt scored better than 16 of his classmates. What percentile is he in? Or something like that. So it just tells you like how he scored better than a certain number. It doesn't tell you how many scored at the same level as Matt. So they're clearly using the second definition. So just to go over the concept with you, I'm going to do it with the traditional at or below. I grew up learning that method. So you would just count how many are at or below that measure. So 69 is what we're looking for, the percentile of 69. So at or below 69, you would count up how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. There are 15 that are at or below a score of 69 out of 20. And so you would convert that to a percent. So that would be the 75%. So that's the 75th percentile. So we don't actually put the percent symbol, which I'm about to erase. We write 75th percentile. So that means that if you got a 69 on this test, you scored better than or equal to 75% of the people who took the test. Okay? You scored 69 means that you scored better than or equal to 75% of people who took that test, who took exam. Okay? And the quartiles that we learned in the box and whisker plot are equivalent to percentiles. So the first quartile is the 25th percentile. The median, or the second quartile, is the 50th percentile. And the third quartile, that number that divides the upper 25% from the lower 75%, is the 75th percentile. Okay, so this relates to the box and whisker plot and how you divide up the data. Next, we're going to look at cumulative frequency. Cumulative frequency is when you add all the frequencies that come before it. So here we have exam scores again. 51 to 60, 20 people scored between 51 and 60. So when you're completing a table, you would put the first value 20. In the next empty slot, though, 40 people scored from 61 to 70. So here you would write 60 because 60 people scored 70 or below. So this really means how many people scored 70 or below. It includes all the people before. And then the next group, 71 to 80, 75 people scored between 75 people scored between 71 and 80. So you would add that group on to this total, so you would end up with 135 people. That's everyone who scored 80 or below. And then continuing on, you would just add on the next number. This would be 195 people who scored 90 or below. And then finally, the last one is 240. This is everyone who scored 100 or below. Everyone who scored 100 or below, well, that's pretty much everyone. Okay, that's the total frequency. That's everyone who took the test. Everyone got 100 or below. So when you graph this, when you graph a cumulative frequency histogram, the bars get progressively taller. And the last bar is always going to be the tallest. That's going to represent your total frequency. This is going to be everybody who took the exam. And down below, you'll notice that your intervals all start with 51 because that's the lowest score. So it's 51 to 60, then it's 51 to 70, 51 to 80, etc. until you're including everybody in the last bar, 51 to 100. Here's another example of a cumulative frequency histogram. Again, identifiable because the bars keep getting taller. And you're going to be asked to analyze certain questions that basically you look at how the bars increased from one to the next. So for example, A, how many scored between 64 and 69? So they don't show you a bar for 64 to 69, but we know that 8 people scored between 55 and 64. And we know that 15 people scored between 55 and 69. So to find the interval between 64 and 69, you subtract these two bars, the heights. So you subtract the 15 minus, because you're basically finding what that gap is here. You subtract 15 minus 8, which is 7. In B, part B, how many students scored between 59 and 64? So 59 to 64. So we know 2 students scored between 55 and 59. And we know 8 students scored between 55 and, and 64. So we're going 59 to 64. So you're going to subtract those two red lines, 8 minus 2, which is 6. So 6 students, basically we're finding the amount that got added on from 59 to 64. Part C, how many students scored higher than 69? So higher than 69, this bar in blue is 55 to 69. So this is everybody who scored 69 or below. So everybody who scored higher than 69 would be the difference from the height of that bar to the height of the last bar, which is everybody. So it would be 20 minus 15, which is 5. Those are the number of kids who scored higher than 69, because this bar represents everyone who was 69 or below. So you're finding the difference basically between the tallest bar and that bar. And then on part D, which 5-point interval contains the median? So let me erase all this. Which 5-point interval? They're telling you basically not the intervals that you see down below, because those are not 5-point. They don't include 5 numbers. 5-point interval is like, just erasing this. A 5-point interval is like when they say, when you're looking at the interval from 59 or 55 to 59 is a 5-point interval. There's 5 numbers there. Or the next 5-point interval would be 60 to 64. Right? It looks like 4 numbers, but if you're counting the 60, that's 5 numbers. Or the next 5-point interval would be 65 to 69. So we're looking at basically the missing part that gets added on to the next bar to then create the next cumulative frequency interval. Okay, so which 5-point interval contains the median? So remember, the median is the middle number, right? So you know that you take the highest bar, you know that there's a total frequency of 20. So if there are 20 people who took the test, and I split that group in half, there'll be 10 people on the left and 10 people on the right. So the median is the average of the 10th and the 11th person's score. The 10th person and the 11th person, that average is the median. So I go to find where the 10th and 11th scores are. So I have, remember these are cumulative. So here, let me erase this. I have in this bar right here, I have the first 8 people. And in this bar over here, I have the first 15 people. So the 10th and 11th person those people are in this group here that got added on from bar A to bar B, I'll call it. So that 10-point interval is, well, if this bar is 55 to 64 and this bar is 55 to 69, then it's the 5-point interval 64 to 69. 64 to 69. That's the 5-point interval that contains the median, because that's where the 10th and 11th scores are. They are somewhere, the first bar A is 8 people and bar B is 15 people, and the 10th and 11th people are somewhere between that, essentially. Okay, you're going to have some of those for homework. And finally, this is something that you're going to talk more about in high school in depth, but distribution of data. If I took your test scores and put them on a graph, I could end up with patterns that look like this, where I have my scores more spread out on the left, my scores more spread out on the right, or I could have things kind of all jumbled up. Ideally, we want what's called a normal curve. A normal curve, or a normal distribution, is in the shape of a bell. You might have heard a bell curve. This is the ideal. So like whenever a teacher gives an exam in any class, they're hoping for something like this, where you have very few scores. This would be like an A range. You shouldn't have a ton of A's, because then your test was too easy. And then down here would have your low grades, like D range. And in the middle, you should have a lot. You should have most people like in the B plus range. That would be like a good exam, like a challenging exam where you have this distribution of scores. In the normal distribution, or the bell curve, the mean and the median and the mode are exactly equal to each other. That's like the perfectly ideal situation. They're exactly the same measure. And so that would be located here. That's your mean, median, and mode. And you have 50% of scores above that and 50% of scores below that. I need to continue on to a different video before it cuts me off.